All right, so I think you've heard a lot of things around inference so far, and compile, of course. I'll be talking a little bit more again. It's all about compile, right? But before that, where did we start this journey from IBM's side, working with the team PyTorch? It was roughly March of 2022 when sort of started talking to team PyTorch and like, hey, there's this new thing called FSDP coming out. Why don't we collaborate on it and see how well FSDP works? So that's what we started. At that point of time, our network was slower, and then we came up with this whole concept of rate limiter, and that's become a API addition to FSDP. It has other benefits beyond doing better memory management. And then we were looking at like, hey, can we use S3 as a backend? And that's where we started working on enabling distributed checkpointing on S3 APIs. Then we were very early adopters of the hybrid sharding approach, fantastic improvements with hybrid sharding just because of the reduction in network traffic. And then, of course, we joined, IBM joined as a premier member very recently. And most recently, we've been working on inference using compile. So I'll go a little bit more into detail. I'm sure many of you have attended Anthony's talk. He's part of my team, and he talked about how do we achieve low latencies on Llama models. And I'll also cover a little bit more on FSDP and what kind of numbers we are seeing in terms of throughput. You can attend Davis's talk later today, which talks in more detail about how do we get there. So let's talk about inference, right? I think many people would have heard about, hey, inference is not part of PyTorch, but I think today things have changed. You've heard that in the opening keynote, and I'm not going to go too much into it, but the way we think about it, inference, is there are three parts in so far: accelerated transformers using SDPA and the faster kernels to your typical flash attention, and then there is, of course, compile, and this brings us great benefits in terms of inference latencies, and the third one is tensor parallel. And why PyTorch native? This way we can run the same piece of code on arbitrary hardware backends. And that's where, again, the whole PyTorch compile, bringing it together and with multiple hardware backends. And today, where we are is, you can go check out the code. We are starting to make many of these pieces open, so you can go experience, including your favorite Hugging Face transformers. You can take that, be able to load our model, and then be able to experience speedups in inference latencies. So what we did was to look at sort of showing the journey that we have taken when we started off with unoptimized eager mode execution, and then we added SDPA, which was probably available as accelerated transformers in February or so, and that gave us another level of speed up, and then, of course, adding compile, and then finally compile with SDPA. And with 70 billion, of course, we had to do some tricks. We had to get tensor parallel implementation, making sure that tensor parallel implementation that we have uses the traceable collectives, and of course, re-implementing the rope embeddings. So with all of this, where are we today? At a 70 billion Llama model on 8 800 GPUs, we were able to measure around 29 to 30 milliseconds per token latency. There are still some gotchas here in the sense that there are some NVIDIA driver bugs that we had discovered working with the team PyTorch, and stability of it is still, we're working on it. But 7 and 13B, you're welcome to go try it out. 70 billion, there is benchmarks that you can go run, benchmark scripts in this repo. So that's something which we are sort of sharing more widely in today's conference. And what is coming is, so that's sort of where inference is, right? So we've also, for a long time, collaborated on the training side of things. And over the course of working with the distributed team, what we noticed is we sort of broke training into two portions. One is the runtime kernels and keep on improving these runtime kernels. So we have benchmarks around what happens when you have unoptimized transformers, what happens when you have accelerated transformers in Flash V1, X-formers, and then what happens when we have Flash V2. We are even working right now on parallel transformers with Team PyTorch, and this is like a completely different way of thinking about transformers. which I'm sure Google has introduced at that point. And from a sharding and memory management, we started off with full sharding, realized that full sharding, when you start scaling the number of GPUs, is causing a lot of network traffic, went into this hybrid sharding mode. Then, of course, better memory management with selective activation checkpointing. And we are looking at, working right now with, on optimal sharding and tensor parallel. So with all of these, what we are sort of doing here is to look at how does each of these pieces give us improvements in terms of the metric that we are using. Two metrics that we use is one is throughput in terms of tokens per second per GPU. And the second is in terms of how do we scale in tokens per day in total. And this is sort of sharing our early results, and still the code and all the other pieces are not yet there in our public repo. We plan on making this available. So these are measurements that we ran on 256 800 GPUs with 400 Gbps networking and GDR. And where we see is going from unoptimized all the way to using selective activation checkpointing. We are looking at around, for 7 billion, 3,000 tokens per second per GPU, and getting fairly close to like 70 billion tokens per day throughput. And this is using FSDP and Flash V2. Actually, maybe this might be Flash V1. I think V2 measurements we have yet to get. I believe it increases a little bit, like almost like 10% or so improvement there. And with 13B, and all of it is focused on Llama architecture, just because state-of-the-art model that's open source, and we have a very good understanding of it. And with 13B, we are looking at 1,600 tokens per second per GPU. So all these measurements are on 256 GPUs. What does this mean, right? You can look at the proportion of the scaling. So this, again, goes to telling us that FSDP is scaling quite well when going from 7 billion to 13 billion model. We do have some early measurements from our 70 billion run as well. These are still maybe like few thousands of steps that we're taking, and they are measured over a course of those thousands of steps. 70 billion is giving us around 300 tokens per second per GPU. And that is, I think we're getting closer and closer to what would be a good state-of-the-art number. And there, we're identifying all these gaps in FSDP, some of the memory-related issues that we are trying to identify. Sharding strategies was a big one, moving to hybrid sharding. Both 7 and 13 are hybrid sharding. When you go to 34 and 70, you need, today it's only full sharding, but we hope to try out the, what is being called as like the optimal sharding strategy, where you keep your model sharded only in a specific number of GPUs, whereas the data parallel is happening within those groups of nodes. And so there's a bunch of things that, things are moving really fast in this place. But we're looking at, compile, of course, is something which we're very interested in for training as well. It's not just, compile for inference, but can we take compile, add it to distributed? And that's another place which, you guys have heard about in the early morning keynote, that making FSDP and compile work together, it's tricky. We are looking at, how can we help there, and then how do we get more involved there? And these should get us to better and better scaling numbers, and let's see how far these numbers will grow in the next few months or so. But the point is that PyTorch core is something that is getting ready for not only large-scale distributed training, but also for inferencing. And both of these are things where, with the introduction of compile, we are getting more and more optimal. So finally, you can go try out. That's a QR code for our repo. You can go try it out. Definitely, please comment. And I like what Joe introduced earlier. We should probably start looking at how do we become an ecosystem project. So definitely going to look at an ecosystem project. And with that, I think that's all I have to share, in terms of inference, where we are and in terms of training where we are. So look to the repo, we'll keep updating it, and we'll make sure that the pre-training numbers and all of this supporting evidence is going to sit in that repo as well.